Ever wondered if traveling faster than light could be a reality and not just a figment of science fiction? This tantalizing concept has long captivated our collective imagination. Picture this: traversing the vastness of the cosmos in mere moments, exploring distant galaxies that would otherwise take millennia to reach. It's an idea that has fueled countless novels, movies, and daydreams. Yet, under the traditional laws of physics, this idea seems to hit a cosmic speed limit. You see, according to Einstein's theory of relativity, nothing can travel faster than light. This is because as an object approaches light speed, its energy increases, and it requires an infinite amount of energy to reach, let alone surpass, light speed. In other words, the speed of light is the ultimate velocity limit in the universe. But what if space itself could be manipulated to allow an object to reach its destination faster than light? That's where the Alcubierre drive comes in. Imagine a spacecraft not moving within space, but moving space around itself. Sounds like science fiction, doesn't it? But this is the fundamental concept behind the Alcubierre drive, a theoretical warp drive proposed by physicist Miguel Alcubierre in 1994. The Alcubierre drive isn't your typical space engine. Instead of propelling a spacecraft through space, this drive manipulates space itself. Here's how it works. The drive contracts or shrinks the space in front of the spacecraft and expands the space behind it. This creates a sort of wave in the fabric of spacetime, with a contraction in front and an expansion at the back. Now imagine a surfer riding a wave. The surfer isn't moving the water. They're staying relatively still on their board, but the wave is moving, carrying the surfer along with it. That's essentially how the Alcubierre drive operates. The spacecraft is the surfer and the wave is the manipulated spacetime. But where does the spacecraft sit in all this? It's placed within a region of flat space known as a warp bubble. This bubble is a disturbance in the fabric of spacetime created by the drive. The spacecraft doesn't move within this bubble. Instead, it's carried along as the region itself moves due to the actions of the drive. Here's the kicker. The spacecraft's local velocity, its speed relative to the deformed spacetime around it, is subluminal, meaning slower than the speed of light. But the speed at which the spacecraft can move through space is superluminal, or faster than light. This means the spacecraft could theoretically reach distant stars in a fraction of the time it would take light to travel the same distance. In essence, the spacecraft isn't breaking any speed limits, it's simply taking advantage of the flexibility of space itself. The Alcubierre drive isn't about moving fast, but moving smart. It's about changing the rules of the game, using the laws of physics to our advantage, and opening up a universe of possibilities. The Alcubierre drive isn't just a far-fetched idea, it's grounded in Einstein's field equations. These are complex equations that describe how matter and energy in the universe interact with the fabric of space and time. The Alcubierre drive is based on a specific solution to these equations, a solution that involves the concept of a metric tensor. To put it simply, a metric tensor is a mathematical construct that describes how distances are measured in a particular region of space. This is where the concept of negative energy density comes into play. The Alcubierre drive assumes that a configurable energy density field lower than that of vacuum or negative mass could be created. This means that the energy of the space inside the warp bubble would be less than the energy of empty space, a condition that is necessary to create the contraction and expansion of space, which the drive is dependent on. However, creating this negative energy density is no small feat. It requires the existence of exotic matter, or the manipulation of dark energy. Exotic matter is a hypothetical type of matter that violates one or more of the classical conditions of general relativity, and dark energy is a form of energy thought to permeate all of space and accelerate the expansion of the universe. This is where the Alcubierre drive, grounded in the realm of theoretical physics, encounters the harsh realities of practical implementation. The exotic matter needed to create negative energy density is, as its name suggests, exotic. It's not something we can just conjure up in a lab. And while dark energy is a major component of our current understanding of the cosmos, our ability to manipulate it is currently non-existent. So although the Alcubierre drive is theoretically possible according to our current understanding of physics, the practical realization of this faster-than-light travel method faces several challenges. We need to find or create the necessary exotic matter, learn how to manipulate dark energy, and figure out how to do all this in a way that doesn't violate any fundamental laws of physics. While the concept is theoretically possible, the practical realization of the Alcubierre drive faces several challenges. The Alcubierre drive is not without its challenges, but that doesn't mean solutions aren't being explored. One of the major hurdles in the realization of the Alcubierre drive is the requirement of exotic matter with the correct properties. This exotic matter, or rather its concept, is something that science has yet to fully understand, let alone produce. The proposed mechanism for the drive implies a negative energy density, which necessitates the existence of this exotic matter or the manipulation of dark energy, both of which remain largely unexplored territories in the realm of physics. However, the road to innovation is rarely without its bumps. Scientists are not deterred by these challenges. In fact, they are motivated by them. One potential solution that has been proposed is the utilization of the Casimir vacuum. This is the vacuum that exists between parallel plates, and it has been argued that this could fulfill the negative energy requirement for the Alcubierre drive. Another significant challenge lies in the incompatibility of general relativity with quantum mechanics. Currently, these two fundamental theories of physics do not play well together, especially when it comes to phenomena like the Alcubierre drive. General relativity allows for the Alcubierre metric, but quantum mechanics may eliminate solutions that allow for backward time travel, thus invalidating the Alcubierre drive. Yet again, this challenge has not gone unanswered. Physicists are hard at work developing a theory of quantum gravity, a theory that would successfully incorporate both general relativity and quantum mechanics. If successful, this theory could potentially resolve the incompatibility issue and bring us one step closer to realizing the Alcubierre drive. In the end, these challenges serve as fuel for scientific exploration, driving us to push the boundaries of our understanding. They are not dead ends, but rather they are detours that guide us towards new avenues of discovery. Despite the challenges, the concept of the Alcubierre drive continues to intrigue scientists and researchers. The Alcubierre drive may still be a speculative idea, but it opens up a world of possibilities. As we look to the future of faster-than-light travel, we can't help but marvel at the potential implications for space exploration and our understanding of the universe. Imagine being able to traverse the vast cosmic distances in a matter of days rather than centuries. The stars and galaxies that seem so far away now could become our next frontier. Recent developments have added a layer of intrigue to this concept. Harold G. White, a researcher funded by DARPA, claimed to have created a real warp bubble. While this is a small step, it's a stride in the direction of making the Alcubierre drive a reality. The road to achieving faster-than-light travel is long and filled with hurdles, but the Alcubierre drive offers a theoretical blueprint that could transform our approach to space travel. While we may still be far from making faster-than-light travel a reality, the Alcubierre drive gives us a glimpse of the exciting possibilities the future of space travel holds.